conversion. Okay, I know that this is BTU per pound mole. I know, and you have to write it, that 550 pound-force foot per second, that is the unit of power. 550 pound-force foot per second is 1 horsepower. And 1 BTU is about 778 pound-force foot. So that is the unit of work. The equivalent unit in SI is joule. Okay? 1 horsepower, so I do the math. 550, which is pound-force foot per second, divided by 1 horsepower equal to how many BTU per hour? Okay, so this unit conversion I have per second, then I multiply by that millisecond within 1 hour, so it will be right now I have pound-force foot, and then I have to change to 1 BTU. I divided by 778. Okay, 550 over that. 1 horsepower becomes that much. 1 pound mole from PV equal to ZNRT, I get 1 pound mole equal to that much cubic foot. Put everything together, then I can get power that can be generated. Maximum possible power that can be generated by this gas expansion. Okay, 40 million, that's the flow rate. I put that in. Okay, I divided by that amount so that I get pound mole. Okay, I divided by 24 because that is flow rate per day. I need a flow rate per hour. So 840, this one is from the enthalpy difference. Okay, for 2,545, that's from here. Review it. So eventually I can get maximum horsepower that much. So this is horsepower created by expansion of the gas. So if someone tries to sell me, okay, we have the gas engine, we have the way that it works is based on we have the gas expansion, and we happen to be able to use the expansion of the gas and draw some power to it from it to do any work. So at most it can do that much. Okay. All right. That is theoretical calculation. Let's take a look at something more realistic, shall we? Okay. So that L06, and make sure that in L06 you have the formula. I mean, this formula to calculate the isentropic horsepower. Okay. Number 7. Okay. For compression, we need compression for vapor recovery unit. Okay. And in the gas plant, in the compression station, if we want to transport gas in a long subsea pipeline, okay, we need to boost the gas pressure to reach the gathering station. We need to boost the gas pressure until it reach the cell pressure, pipeline pressure. Okay, read that. Vapor recovery unit distribution station. There are 2 types of compressor. Type 1, PD, positive displacement. Type 2, dynamic type. Positive displacement means it physically compresses the gas. The piston type reciprocating compressor that physically compress it, make the volume go down, apply the force to make the volume go down. That is positive displacement type. Mechanically reduce the volume to increase the pressure. Okay. Rotary compressor is have straight lobe, helical-Lobe, sliding vane that you will see shortly. So that is use mechanical force to compress it. We call positive displacement type. Sometimes you see something that is spinning, it turning very quick. It doesn't need to be dynamic type. Dynamic type we have radial flow, centrifugal type, axial flow. Okay. We can have single stage, multi-stage, vertical split, blah blah blah. Let's take a look at it. Which one we use in what case? Reciprocating compressor, multi-stage. is this part. So we want high discharge pressure. We don't need much flow rate, but we have high discharge pressure. Okay? Use reciprocating compressor. If we want high flow rate, okay, you see this flow rate. If we want high flow rate, use multi-stage centrifugal compressor. Okay? When it spins, it can do more flow rate. It may not give us much pressure. Okay? When it compresses, it's quite efficient, but it doesn't flow fast. But we can get high pressure. Of course, we have rotary sliding vane, rotary straight lobe. Okay, we have several types: axial, screw, and so on. Okay, this is a chart to use as a guideline. All right. What kind of compressor? Oh, let me call it name. Lewis air floating press. Okay, Lewis air floating press. Do you remember Weber recovery unit at the field trip on the East Campus OTC? It looks like it's have what color? First of all,
I think it's green.
green. Really? The compressor itself. The compressor itself, not the color of the tank or anything. The color of the compression chamber, the cylinder. What is that color? It is blue, and we call Quincy pump. It works by have a piston inside, move up down. So that type that have piston inside, is that PD or dynamic? PD or centrifugal? Lewis lowering glass. PD or centrifugal? It's just two choices, come on. What?
The Vane-Type.
When it have piston inside, let me repeat my question. Mr. Lewis, when it have piston inside, would you like, is that PD type or dynamic type, sir?
PD.
Oh, correct. Very good. Okay, let's move on. So, compressor, the Weber recovery unit can have the screw type, okay? And you will see, okay, axial compressor, how does it look like? It's used in the jet engine, okay? Multi-stage axial compressor, that's in the plane, jet engine. So this is a big centrifugal type. And Mr. Bullard, where else do we use that? You talked about offshore last year, that we use any of that?
Yeah. So those turbine pumps, or turbine compressors you hear referred to, are used to move very high volume. We used them in the Middle East on offshore platforms. These were 12,500 horsepower units. They were moving about 125 million cubic feet a day through each compressor. Then we get two trains of those compressing gas to gas bed. We have 250 million a day total gas bed on two of those. And then those same type compressor engines were used to turn water flood pumps. We have 4 water flood pumps for 500,000 barrels a day of water, 4 pumps. And all those are 12,500 horsepower engines. When you go in there to work on the rotors, you stand just, I can almost stand up.
Okay, so we use compressor in multiple places: fuel gathering station, recycling station, storage field station. So when we produce gas, we want to increase the pressure, we use the compressor. If we produce a lot, we may use centrifugal type on this stage. Okay, we are not going to that much detail, but what I want you to know is, how does it look like? How does it work? Which type is which? Okay. Okay, now we have this one. That is reciprocating compressor. We have screw compressor. Okay. Screw compressor is PD type, positive displacement. Reciprocating compressor or recip unit, that is PD type. When it has piston, move back and forth. The supercharger, two lobe. We have two lobe spinning. Even though it's spinning, this thing is PD type. Okay? And let's take a look at how does it look like for each of them. Okay, that's not the video. Okay, I think here's it. Let's give it a little bit. Reciprocating unit from GE. The sound doesn't do anything. Okay. Alright, it is that big. Where is it? You see the red thing? We go up the stair. Alright, after we go up the stair, of course it's proven and everything. So we have 6 cylinders. You see the number of cylinders? And it's that big. Or it's spinning.
So is this is a 3-stage though, but it's doing 2 strings simultaneously?
Is it 3 stage? It has 3 sides. Big one has to be first stage, right? Smaller one. So when it has 3 sides, I would guess this is 3 stage. Okay, inside it have a double acting piston. What is double acting piston? You see sometimes it's blue. You see that blue? Sometimes blue become red. Blue and red, blue. So red is kind of high pressure, blue is lower pressure. So it compresses when it push and when it pull. Okay. So this we have crankshaft, one crankshaft revolution. It compressed 2 times. So that has to be double acting. Okay. So when this thing spin 1 revolution, it compress, it go in and it come out, it compress both ways. It compress twice, so that is double acting. Okay, this is internal part. On top there's a valve. It's open and closed by itself. You see there's no like power or something. The valve just open based on the pressure. Okay. Let's take a look at the valve closely. It move just a little bit, okay? But it can do like this. When we take it apart, it looks like that. And that is the valve. Have the spring on the top. You see that spring on the top? Put them together. And it has multi-stage. So the number of piston, how many piston do we have? Louis lowering gas. How many pistons do we have for this unit? 6. When we have 6 pistons, we call 6 throw. Okay, 6 throw. THROW. 6 throw. That is on this page. 6 throw. So the number of pistons is the number of throw. Okay. So when we have like 1, 2, 3, 4 piston, that is 6 throw. And does it mean that it have 6 stage? No. The number of stage depends on how many cycles that we compress it. When we have 3 sides, okay, biggest one will be the first stage, smaller one will be second stage, and the third one, the smallest will be the third stage. So in this picture, we have 1 big cylinder, 1 small cylinder. So I would guess we have 2 stages. Okay? Let's go back to other video. We'll do more on that. So reciprocating compressor is positive displacement type. Okay, positive displacement type. So this is screw compressor, and that is supercharger. The way that screw compressor work, we can use that in a vapor recovery unit. The way that it works, in between there's a liquid or oil to seal it, make it seal. Gas move along this screw groove, and then the area get less and less and less. That's why the pressure go up. I think we have video at the end. All right. Gas compressor compress flash gas to gas cell pipeline, allow water to operate at lower pressure than the gas cell pipeline. And this is where we have it. Rotary blower. Okay, one type of compressor. It has large rate, low pressure ratio, low initial cost, low maintenance cost. It has some noise. It can overheat. So the way it works is it have gas coming in from the bottom, okay, and it go to the side and then come out on the top, okay. Rotary blower, Colton T-shot. Is this centrifugal type?
Looks like a displacement.
Positive displacement type, correct. So we physically move the volume, okay, this is positive displacement type. Centrifugal compressor, it have high capacity, low pressure ratio, okay, low maintenance cost too. Reciprocating compressor, okay, it have a electric motor. We use it. It physically compress it. When we have this, it have more moving part. It can have a pulse. When we push it out, the downstream feel the pulse of the gas coming out. Okay, it may shaking, it move like this back and forth. Right, the gas that coming out may come out as a pulse. Okay, we will have to do something with it. Number of flow is the number of piston. Number of stage is the number of cycle that we do compression. Number of acting is the number of time that the compression happen per one crankshaft revolution. Okay, so this red part is the crankshaft, and that's a piston and the cylinder. So if it compress both way, that will be double acting. If it compress and another side doesn't have anything, that is single acting. Okay, your job is explain what is the difference between acting and stage. Okay, what is the difference between number of throw and stage and acting? You have to know that. High-speed compressor, low-speed compressor. Reciprocating compressor can have high-speed unit. High-speed unit look like this. Okay, high-speed unit they call separable unit because the box in the middle that have the crankshaft is separated from the cylinder itself. So this is separable unit. So when you see this picture, it's a high-speed reciprocating compressor and it's a separable unit. So high-speed means is do about 900 to 1000 RPM. Okay, non-reciprocal. Slow speed typically is an integral unit, and you will see shortly how does it look like for the integral unit. Okay, high-speed recip can have 3000 horsepower. Okay, we can put it on the skid. Self-contained, low cost, lower cost. Okay, this one is also important. In general, high-speed reciprocating compressor has higher cost than the slow-speed reciprocating compressor. True or false? And you say false, for example. Okay, so you need to know that it's lower cost in general compared to the low speed. And we can put it on skid like this. You see the skid on the bottom. Skid is the like a unit, the structure that you put everything on. So when you see this, you see that throw. This is it high speed compressor or low speed compressor? High, right? Is it separable? Yes, it is separable unit. And what are those tanks? Scrubber, you know that, right? First stage will be bigger than the second stage. So I give you this picture. I say this compressor has two stages. I show you that and show you a bigger one. which one is the first stage. You have to be able to tell the bigger one is the first stage.
How
The-
do you think it's high speed by looking
if it is separable. In the picture, we cannot tell the speed. Even you sit over there, you cannot tell the speed. It's happening inside. Right? But when it is separable, when it looks just like that, or like the video that you have seen, that's high speed. Okay? When it's low speed, it looks like this. Integral unit. You see the crankshaft, everything, the piston. Okay, it's kind of get all together. It's not like separable. You cannot separate it easily. So when it's like a V shape on the top, this is a integral unit. You see the engine, okay, and it's a cylinder. So this kind of thing is integral unit. So integral unit is slow speed, low speed. Okay, that's the drawing. Okay, disadvantage of high speed is not as fuel efficient as integral engine. Okay, so you have this much BTU per brake horsepower per hour. Okay. Alright, brake horsepower is a horsepower, the amount of external force that can be developed by the engine. The number of horse that required to brake the engine, that's the brake horsepower. Okay? Measure directly over this part. Okay? The power before it loses to anything, the true power from the engine. That's the brake horsepower. It have medium range efficiency, short life, compared to low speed, higher maintenance cost. Your job is memorize one. Okay, I'm not talking about you have to know everything. You may memorize this. Okay, lower fuel consumption, lower fuel efficiency compared to integral. But you will say, okay, higher maintenance cost. Does it cost more or it costs less? It costs less. Okay, that's advantage. Disadvantage. Memorize one advantage, one disadvantage. Okay, it can put on the skid for the integral unit. You will see that like in the gas plant, typically it's like very large. Okay, very large and require fuel erected. Can be skid for small horsepower, but it's not quite general. In general, it's very clean. Okay, and the advantage is greater fuel efficiency. Okay, and we have everything. Okay, cost and weight are much higher than similar size high-speed separable unit. So when you see this picture, I have limited number of pictures. Okay, I cannot quiz you or give you the example on many other pictures. I don't want to find more. When you see this picture, it is integral unit. Okay, look how big it is. Very big, right? So this is integral unit. When you see this one, like in the video, this is separable. It doesn't have like a V shape at the top. So this is what? Separable high speed. So when it looks like this, that is integral compressor. Almost done. You know the theory. Low speed receive. You see this time we can do 2,000, 12,000, okay, up to 12,000 horsepower. What about high speed? High speed we do how much? 50 to 3,000 horsepower. So 50 to 3,000 horsepower is not a number to memorize, but what I want to say is like high-speed reciprocating compressor generally has less horsepower or horsepower range compared to slow speed. Low speed is big. It can be like 10,000 horsepower, okay? And higher fuel efficiency, longer life or something. Disadvantage, require heavy foundation, otherwise it's gonna shake. Okay, high installation cost. Read the rest. Let's go over a couple of these and then we end. How about that? Vane-Type. Vane-Type compressor, we can have vane pump. The way that it works is it have vane move in and out, okay? It moves in and out. Gas coming in over here, and it's going out over there. So the way it works is physically compress the gas. So if you look at this chamber, it has big volume compared to this part, right? It has eccentric center. Center over here is eccentric. So the volume of gas that is occupied in this chamber, when it moves, the vane keeps going in because we squeeze it against the wall. So we squeeze it against the wall. So this vane coming back in more, coming back in more. So the volume is less, the volume is more here. So we physically compress it that way when we spin. So this type is what type? PD? You agree with me? Yes, I say yes. Okay, let's move on. So this is PD. So the rest, try to at least know one of these, okay? Whether it's positive displacement type or what. Alright, Vane-Type compressor, it can do vacuum pressure, okay? That's one of the good things. Extensively used in the rotary unit and vacuum pump, okay? Size is not like high horsepower. So if we have something that is 10,000 horsepower, should it typically be the Vane-Type compressor? True or false? No. 10,000 horsepower is usually be low speed reciprocating compressor, not this Vane-Type. Okay. Good in vacuum service, no power setting, less space, inexpensive for VRU. Okay. Must have clear air or gas. Requires some more horsepower. Use 10 times of oil of reciprocating unit. Why does it use a lot of oil? 10 times of oil of reciprocating unit. Why is that? Because this have to have some oil over here to seal it. Okay? It have some oil to seal it. Helical-Lobe. Okay. What you need to know is like just one of these. Okay. Can be used as oil-free. Okay. Non-lubricant. We can have two helical rotary. Trap the gas in the middle. Some type need it can be used in a VRU. It needs oil and it can handle dirty gas because there is no metallic contact. Can handle moderate amount of liquid. So that is dirty gas. Where do we have dirty gas? Before the refinery, we have dirty gas, right? If we don't remove any dust or any particle, we have dirty gas. So dirty gas happen on the tank battery, vapor recovery unit. They can use this screw compressor, okay? It looks like that. That is the size. So we typically don't use this for vacuum. Okay, not as good as Vane for vacuum. Alright, for vacuum service we use Vane-Type. And this I show you. This one is in high bond. Okay, in Midland we have a screw compressor. Helical-Lobe. And can handle dirty gas, blah blah blah. Read that. Most of them doesn't have pulsating flow. Okay, except reciprocating compressor. Why is that? Why is that? Intro. Okay, the gas coming out from recipient is not continuous, but helical-Lobe or two-lobe, it spin and it coming out continuously. Even the Vane-Type is coming out continuously, so it doesn't have that much pulsating flow. Disadvantage of the VC over here is a vapor recovery unit. It have if we do some 50 psi, it can take a little bit more horsepower than reciprocating compressor. Okay, low tolerance in change in operating condition. So that's just the overview. Centrifugal compressor, it can do multi-stage, and it can do like 20,000 horsepower and high horsepower per unit space and weight. Okay, so we don't require much space, but it have high horsepower. You read the list. Okay, large capacity, it can do basically do high volume, and so generally it have high volume, low ratio compression. If you don't want to compress it much, but you need high volume, like in a gas lift service, we use centrifugal compressor. So by now you should know that, okay, screw compressor can handle dirty gas. Okay, it's used in vapor recovery unit. If we do high volume, okay, like gas lift service, we use centrifugal pump or centrifugal compressor. It have lower compressor efficiency because we spin unit, we compress it directly, but this time we spin it and convert from kinetic energy to increase the power. Not for low volume, high compression ratio application. So in the exam, if I ask you, should we use PD compressor or centrifugal compressor in general to produce low volume, high compression ratio? You should be able to tell me, right? Low volume, high compression ratio, we don't use centrifugal type. We don't use centrifugal compressor in general. Read the list, the leftover, okay. How do we size the compressor? We do like what we did last time. Okay, we have this equation. Number one is compression ratio less than 3, at most 4. There are several ways, or at least 2 ways to calculate brake horsepower. You have seen the equation from the theoretical part, right? Here's new equation, easier. 22 multiplied by number of stage, or compression ratio. Compression ratio stage means compression ratio per stage. Okay, this is compression ratio per stage. Multiplied by F, multiplied by QG, then we get brake horsepower. Approximate horsepower to brake that crankshaft revolution, okay, or the power that it generates. F is 1, or that much for single, 2, and 3 stage compression. Okay, if you have more stage compression, F value change. So this is easy equation to use, okay? But it's not going to be as accurate as the one that is longer. Or we can use a chart. Make sure that every way that we do it, they look the same. Okay? You should get the same number. So this is graphical method. Base horsepower per million cubic foot per day at 14.4 psi, and suction temperature of something. Okay, we have overall compression ratio based on the absolute pressure. Typically, compression ratio is between 3 and 4, right? And we have 1 stage, 2 stage, and this is K value. Upper line is K equal to 1.4 diatomic gas, like N2. For lower line, K equal to 1.1. So if we know the K value, we know the compression ratio. When I have compression ratio, I know that it's 2 stage. And then I can read this base horsepower per million cubic foot. Good. So these 2 lines is for VHP calculation. The top line is for temperature. Okay, the top line is for temperature. Why is it for temperature? Okay. Also, 1000 BTU per hour to cool gas back to the original suction temperature. So it's about the BTU per hour. So this axis have 2 purposes. Number 1 is brake horsepower. Number 2 is, it's not temperature, I'm sorry, it's about the BTU per hour to cool the gas back. Okay. If we know the compression ratio, we know that, okay, suction temperature has to be 50, then we rate it. We know the number of BTU per hour that we have to cool it. If I don't do this, what else can I do? I can read the chart, right? And the chart, the difference in the delta H, we can do this. You remember the chart that we do last slide? Modular diagram that get H, get delta H, and we do the difference in the enthalpy that is used for the cooling calculation. This is to give you some idea how much is the actual compression ratio. Compression ratio of 2, booster 2.7, 2.7, that's gas lift, flash gas, vapor recovery unit 433. Sometimes we do, most likely they do centrifugal, high speed receive, centrifugal, sometimes screw. So for VRU we can do vane, screw, and high speed receive. Okay. Alright, so when you see this one, typically compression ratio is like less than 4, right? 4 is at most. And number of stages is 1, 2, 3. Okay. Temperature at the discharge temperature, more accurate method is use this. Okay. This is giving me the temperature. Alright. You see this eta polytropic efficiency, we use 1 for received unit and 0.8 for centrifugal type. Okay, discharge pressure, discharge temperature. D is discharge, S is suction. Benjamin C. Shipley. Benjamin, where's Benjamin? What is this TD? Is that discharge after each stage or discharge at the end of every place? Each stage. So this is for each stage. And that number is stage discharge. Don't use as a total. So this is actually compression ratio, right? That will be each stage compression ratio, not total compression ratio. The temperature, discharge temperature should be less than 275. Okay, at 300 F, it catch fire. Okay, that's not good. So too hot, it reduces the efficiency and it's not safe. So 250 to 75 is okay. More greater than 22 multiplied by something is this equation. Okay, this equation is different than the equation that you got earlier. It looks similar, but it's not the same. That's one that you have is isentropic. Okay, ideal horsepower. This one is the actual horsepower. They call brake horsepower. In HP, we have average compressibility factor. We have K value. Is this K value at the inlet? Yes, even though it's different than the outlet. Eta come from previous slide, 0.8 or 1. Okay, and we have compression ratio per stage. E is that efficiency. Use 0.82 for high speed receive, 0.85 low speed receive, 0.72 for centrifugal unit. So here's another equation. Your job is have the value in, get the result. Compare this with the answer from the chart and the answer from this equation that has 22 multiplied by something. Right? 22 multiplied by number of stage. I cannot find it. Okay, yeah. Okay, compare with that. My phone is still 12, 19. Okay? So when we use it in the different elevation, we have to be ready. We multiply by some other value because when we go up in elevation, we need horsepower to compress gas that is less there. All is self-ready. Thank you for coming. We will see you next time. We do not have class on this coming Thursday, but you have homework still, and you have to do homework. Okay?